So in this video, I'm going to give you kind of a rough summary of the XRD analysis that you're going to want to do for polymers. So I've got FIDIC open. So this is the same software that you used for the XRD lab, but I've got all the samples pulled up for the various teams. So you'll see over here in data, I've got sample 1, 2, all the way to 8, which is what we have for the polymer lab. So the peak fitting process is the same as what it was before. So how you go through and fit a background and find the peaks, all of that is the same. The main difference here is that these are polymers, and as opposed to the metals that we had in the XRD lab, and so the pattern can look quite a bit different in some cases. So basically, there's some things that you should ask yourself. So let's kind of go through some of these various patterns. So let's start with this one. So this is sample 6, and it's A. So there's actually two patterns that I have for sample 6, because we see quite a bit of sample to sample variation with sample 6 from year to year when we buy it from the supplier. So we gave you both. So if we just look at this, so there's not much of a pattern going on. There's this really wide peak here, and so basically, if we don't see much in the signal other than this very wide pattern, which actually, if you go back to some of the metal patterns, you might have even seen something similar to this. You'll notice that the overall counts are very low, right? So if you compare it to one of the other samples, you can see how much higher they are, the total counts here. And so overall, the counts are very low. And so when you see something like this tells you some information, even if it doesn't have a lot here. There's not a whole lot of peaks here. So basically, what does this tell you it is, right? So you can find patterns similar to this. You can look in our characterization textbook and see similar patterns to this in the later sections that we didn't get to in the XRD chapter. You'll see versions of this. So, what is this very broad peak called? What type of material or polymer does it tell you we have? So that's the first thing. Also, we may get samples like B. So this is, again, the same sample, but here, again, we see a same general kind of mound almost around 20 degrees if you compare that to the other, right? But there's now little peaks kind of emerging from that. And so that tells you some more information about the type of polymer that we have in terms of the crystallinity. So what does that tell you in a qualitative manner? And so the fact that these two look like this gives you information about the various states in those two types subsamples that we have for 6. And so you may see similarities between yours. So sample 5, for example, has a similar type of appearance. It's this very broad looking hump, but then there is some small peaks that jut off of that kind of mound, right? And so a lot of yours might look like that. And then we get to the other kind of extreme. And so let's look at something like 4, and I think what else? And 4 and 2, you see here, they have pretty distinct peaks, right? If we look at both of those, pretty distinct peaks, and lots more of them than some of the other patterns, right? So again, that tells you something compared to what the others told us. So we get, obviously, if there are peaks, we get despacings and we get what plane that corresponds to and so forth. But also you get a lot of qualitative information about the crystallinity of these polymers. And again, I'd refer you to the XRD chapter in Ling to help you out with some of this information. All right, so that's going to be what we're going to have to look at. The other part here is that in the XRD lab, we showed you how to index cubic materials using that technique that used a spreadsheet and so forth. For polymers, this isn't something we can normally do. And so for polymers, what we're going to have to do is we can't rely on indexing these patterns and using some kind of procedure to determine the structure. What we're going to have to end up doing is do our normal peak fitting procedure that we would do, make observations about the state of the polymer, how crystalline it is. And then what we're going to have to do is, based on all of the other information that we get through the course of this lab, so mechanical properties, density, DSC measurements, all of those properties are going to give us a shorter list of polymers that our samples could be. And then what we're going to have to do with that is go and find patterns for those proposed materials and do kind of a one-to-one comparison to those materials. If we're trying to do a comparison, we have our pattern for our sample, and let's say we have a narrow list of 5 to 10 polymers. So let's say I think one of my polymers is polypropylene. So I can do a quick search of polypropylene. Usually just if you do polypropylene XRD and look at the image search, you can find things. And then most of these are going to be tied back to an article. So, make sure the citation is reputable. So the best way would be is if it references back to a paper. And so then you can go back and make sure that the procedures is very similar to yours. So make sure they're using the same X-ray source as you so that you can compare the peak locations. So let's say I think it's polypropylene. I've got this one up here. And so I can try to match and say, well, I know where this, and this is, and try to kind of overlay that to the pattern that I have and see if I get a match that way. So it's going to be more of a manual method comparing patterns that you see in the literature to ones that you recorded in our XRD lab. So again, this is where you'll probably want to wait until the last step, where you've got a very short list of polymers, potentially only 2 or 3, that you then find reputable XRD patterns for those materials and compare that to your own sample, and you'll find that at that point it's much easier to get a match when you only have to look at a few different possibilities. And we've done this in previous semesters, and we can typically find reasonable references for all of our samples and get good values, as long as you've got a list of samples using the other properties that you have. So you got to get that short list first. So that's going to be the real trick to this, is wait until you get the others to sort of do your final XRD analysis and then look and see if you can match some patterns directly this way.